Hello everyone, so today we are solving this problem, cousin in binary tree. So given the root of a binary tree, replace the value of each node in the tree with the sum of all of its cousin values. So cousin is something like any two nodes are cousin if their father's father is same. For example, here you can take an example of this node, value having 1 and the value having 7, right? So 4 and 9 are their corresponding fathers and their father is same, which is 5. So we can say directly 1 and 7 are the cousins, but 1 and 10 are siblings because their father itself is same. So if father's father is same, then those guys are cousin. So what we have to do basically is we have to replace the value of each node in the tree with the sum of all of its cousins. So there could be multiple cousins, so the node value has to be replaced with the sum of all of its cousin. This is what we have to do. So we can take one example. For example, this is the node, right? This is the one tree, okay, one binary tree B. So here, see, come to this point 5. Does this guy have any cousin? No, it doesn't have any cousin, not even father. Okay, so what would be, if there is no cousin, that means there is no value, so we have to put 0. So for this guy we have to put 0. Come to this point. Does 4, this node has any cousin? No, it has father, but there is no cousin, right? So this guy also having value 0. Come to this point, this guy also doesn't have any cousin, only father they have, so this guy also will be 0. Now come to this point 1. Does it have cousin? So who is its father? Father is 4 and his father's father is 5. So is there any node who has father's father is 5? Yes, 7 has father's father as 5, right? So what we can do instead of this, so how many cousins are there? So only, unfortunately, only one cousin. So sum would be 7, right? So instead of 1 we have to put here 7, right? Now come to this guy. How many cousins this have? This guy also have only one cousin, the value 7. So we have to put the sum as 7, right? So we are done for this guy as well. Now we are coming to 9. Hey, 9 has any cousin? No, only father. Now 7. This guy has two cousins, 1 and 10, right? We already discussed. So 1 and 10 has, so 1 and 10. So sum of them, it would be 11, right? 1 plus 10, 11. So we have to put here instead of 7, we have to put 11. So this is what we have to do. Okay. So just before going to approach, I will tell you what is the intention behind that approach. So you guys can assume here, let's say I'm drawing a line. Okay. So anywhere, this is the label, right? Okay, you can consider, okay, just me remove this thing, we will consider only the input array. Okay, so see here, this is our label, right? So at any label other than the siblings, everyone else is the cousin, right? So for example, this one has one sibling 10 and rest all would be the its cousin only, correct? So we can have one intention here. If we sum up, if I do the sum of all of them, what it would be? It would be 10 plus 1, so it would be 18, right? So its sum of this label would be 18. But to get the exact value, what if I have done, instead of putting here 1, if I put the sum of the siblings values? Okay, for example, here instead of 1 and 10, 11, right? I could have put 11 and 11 at both places, right, instead of 1 and 10, because it is simple, right? For its sibling we can easily do that. So 11 and 11 we could have put like this. Now if I go for the sum, the total sum is 18, correct? And from this 18, if I deduct the actual value of this, whatever value we have, the sum 11, right? So if I put 18 minus 11, this will actually give me the correct answer. You do 18 minus 11, this is giving me 7 here. Similarly here also the sum is label sum is 18, right? And its value is updated as 11. So 18 minus 11, here also it is 7. Now come to this point. This guy was having 7 because only one sibling it has itself only. So 18 minus 7, here it is giving me 11 directly, correct? So our intention is to at every level we will put the node as the sum of that guy and its corresponding sibling if it is available. So instead of actual value, we will push them with the value and its sibling value sum. Okay. So this would be our approach, and we will go in simple BFS way. So let's go, what would be my further approaches. So guys, you can observe here is what I'm doing is I have created one queue of the nodes, right? Tree nodes. So I have one variable called previous. So initially I have put the previous equal to 5 in the sense the root value. Okay. And I have pushed this root into the queue. Okay. So initially we started with this way. Now once we have pushed, we will start a kind of while loop, that while this queue is not empty, we will keep on popping the values from it. Okay, so let's say at this time it is 5. So suppose I have put that into a variable called temp. Okay, so what I would do is my approach is here. First of all, I just popped it out. Okay, so this is the node, right? This guy is the node. Now what we have to do is first of all we have to look for the left and right child of it, because we're gonna push it. So at every level we are getting the size, right? So this time this is sizes would be 1, right? So we just put every time we are taking the size. So for example, this time it is 1, so we have popped it out. So one time we have run and one time we popped out this element. So this is the temp. Now what we will do is we will look for the who is the left and right child. So see here, 4 and 9 are the left and right child. Okay, so what I will do is instead of pushing these left and right child directly, I will keep on pushing them with the sum of the siblings. For example, in this way, this left guy value, so left, well, what it would be, it would become basically the 4 plus 9, right? So I will do 4 plus 9, so it would be 13, correct? So I will push here 13. Okay, so this guy would be having everything is same, only its value is pushed like this. So this will become 13. Okay, and this also would be 13. Okay, so we can call this value as a left right value. Okay, so for example, if I call it left right value LR, so LR value here it become 13. Okay, so in one variable I will keep on summing the LR values as well. Okay, so let me remove this. So LR values came here 13, and because there could be multiple values as well at every level. Okay, so we need the sum of all the LR values. Basically we need the sum of all these guys who are sitting at the same level. Okay, so see here, for every left right pair we made it 13, and we will keep on summing. So this time it is only one pair, so it is current value is also 13. Okay, so let's say CV current value is also 13. Okay, now we are done for this level. So once we are done for this level, okay, at any point of time, whenever we are done for a level, basically we are assign this current value, the basically the sum of the all left right pair sum, we will make this previous equal to this value. So now previous would become 13 here. Okay, okay, so I have made it 13. So now we are coming to this queue. This time it is size is 2, right? So 2 times we will execute this code. So now before going to this, what we will do is before going to another cycle of it, we will also update the value of temp. Okay, so temp would become what, as we already discussed our intuition, right? So temp would be become whatever the previous value, okay, whatever the previous value minus temp dot current value. Okay, so temp dot current value. So what was the previous value? Previous value was 5, and what was the temp dot current value? It was also 5. So 5 minus 5, so this would become what? This would become 0. So that is why we have made it 0. Okay, now after updating for the very first, now we are going for the next cycle of it. Okay, so this time what will happen? This time we have to run the our code 2 times, because size is, we are running behind the size, so size is 2 here, so we have to run it 2 times. Okay, so we will come to very first guy. So this is 13. Okay, so its node value is 13, but all other references are still same. Okay, so we will take this guy. Now our new previous value is 13. Okay, so we have to go to this guy 4. Basically its reference would be 4, but we will go for it. So what is the left right value? Left right value would be 11. Okay, so this would be 11, and current value is CB plus equal to LR. Okay, current value equal to current value plus LR. So current value currently it would be 11 only. Okay, this would be 11, and right now our temp is basically this guy 13 node. Okay, so let me call it as a node formation. So I'm popping out this guy. Okay, Now what is the left right value? We already found it is 1 plus 10, 11. Okay, so we have to basically post 1 and 10, right, with the 11 value. Okay, so what we will do is basically this would be posted at the value 11, and this also would be posted with the value 11 because we are posting at the sum of them. This guy also posted with the value 11. Okay, now we have the next value here. This is 13, right? We have to pop that guy as well. 13 is the anchoring for this guy only. Yeah. Okay, so don't get confused this. So this guy is, let's say I'm calling it again 13. I'm removing this guy from here now. Okay, so I just removed. Now what we will do is we will look for the left and right value of it. So what is the left right value? Left is actually null, so no value. Right is actually 7. Okay, so left right value basically it would become 7. Okay, so so CB value would 11 plus 7 because we are still at the same level. So 11 plus 7, it would become 18. Okay, so it would become 18. So now this guy don't have left child, right? So left child we will not able to push anything here, but this guy has right child 7, right? So we will push this guy as that's the value 7. This guy has right child only, it doesn't have the left child, so it is 7, and left right value is also 7. So we will put this guy as it is. This guy would be having 7 value only. Okay, so we are done till here. Now when we are coming out of them, we have to do that value as well, right? We have to update the values of them. So temp equal to temp minus what? Temp equal to previous minus temp dot cur value. So it was previous minus cur value, temp dot cur. So what is the temp dot cur at 4, right? So previous value it was, we have 13, right? We stored with the 13. So it was 13 minus, what was the left right value here? It was also 13. 9 plus 4, it was 13. So 13 minus 13, this also becomes 0. Similarly for 9 as well, we stored with the 13 value, right? Previous value, right? So that was also 13. So 13 minus 13, previous is also 13. So 13 minus 13, this is also 0, right? Now our left, now we are done for this. So we will assign this value 18, the current value to the previous value. So new value here, it would be 18. Okay, so we are done for this. So I am removing all these values. Okay, so I am removing this previous minus temp dot val. This is what we have to do. So next value is 11. So we'll pop this out first of all. So let me pop it out. So that means we are removing it from here. Okay, so we are removing it. That means it is anchoring for this guy basically. So what is the left right? Left right is 0. So no addition. So this time our this LR became 0, right? Because we are at new level. Left right value is equal to 0. CV is also, as currently it is only 0 only. So let me remove these guys. Current value is also 0 because there is no left child and no right child. Okay, so at this guy. So what we will do? Previous minus temp dot value. So previous is what? Previous is 18. Okay, previous is 18, and what is the temp dot val? Temp dot val was 11. We popped out 11, right? So 18 minus 11. So what would be the value? Value would be 7. So we updated here 7. Now come to this guy. This guy also 11. Okay, we will pop this guy out. Okay, I just popped it out. So left right value is 0 because there is no left child, no right child at this guy. Okay, so current value is also 0. Now go to previous minus temp dot value. Okay, so previous is 18 and temp dot value is equal to 11. Correct, we had the 11, we just popped out 11. So 18 minus 11, so this guy is also equal to 7 only. Okay, now we have left only this guy 7, right? We counted with the 3, right? So what we will do, we will pop this out. Okay, so let's remove this guy as well. So we popped it out, and so there is no left right child. See here, so left value is also 0, current value is also 0. So previous is 18. 18 minus, what was the value of it? 18 minus 7, right? The one which we popped out is 7. So we will put it here 7. So 18 minus 7, what will be the value? Value would be 11. So we have updated the 11. Now because there is no left right child, so we haven't put anything, right? So our queue is now empty. Now because it is empty, so there is no more process. So we have already updated everything. So this should be very simple. You guys can take your pen and paper and make further more sure for it. So let me show you my corresponding code for it. Okay. So see here, this is my code. So first of all, see here what I have created one queue, and this is my this value previous, which I started with the root dot value. Initially I have posted the root value into our node as it is. Okay. So see here, what I am doing is, first of all, while queue is not empty, we are taking the size of it because we are pushing the values, but we are interested whatever size we have, because we have to go in the level wise. So once we are taking one size, that means that many nodes would be for the same level. That is why I am running for the size time. And this is my cur value, which integer, which I will use later. So now come to this here, we are popping out the element from the queue. Now see here, this is my left right value. So if left is not null, temp dot left. Okay, we popped out into temp. So if temp dot left is not null, then I am adding this temp dot left dot value. Plus if temp dot right is not null, then I am adding the temp dot right dot val, because we need the left right value, basically the sum of the sibling values. Okay, so then I am getting it into this variable left right. Now see here, we are checking, hey, is there left is null? If it is not null, then only it makes sense to push it. But see here, before pushing it, what I am doing, I am updating this value temp dot left dot val equal to left right. Just we did right here. For 4 we added 11, right? Because left right value was 11. So instead of 4 we pushed it into with the value 11. Only that thing we updated. So same value I am doing here. So if it is not done, update the value with left right and push it into the queue. Similarly do for the right child as well. Okay, we are for right child also we are updating with the left right value. Now see here, there is a one variable cur. So cur equal to cur plus left right value, because we are getting the sum of the all nodes in the same level, right? We were doing here, we did here, see, for them we got 11, right? But for this guy we added all of them, right? So it was giving us, this pair was giving us left right value as 11, and this was giving 7, right? So our this label previous value will become the 18, right? So for that same thing I'm doing here. So we are adding them up for this current label left right value. And so whatever we popped out, we popped out here this temp, right? We did all these updates and pushed its child to the queue. But now here it is the time to update the temp value itself, right? So he see here, temp dot value equal to previous minus temp dot val, because we updated temp dot val every time with the left right sum. So we did this, and now at this point we are basically updating to what would be the final value in our node, and every time we are decreasing the size minus minus. Okay, so once we are come out of this while loop, once we are come out of this while loop, we will again go to top of it, right, till the time it is not empty. Okay, so then we will again call all these things. So for every level we are doing this. So then finally what we are doing, finally see here I am assigning the previous value into the whatever value we calculated from the current level, okay, which would be used in the next level. So finally I am returning the root itself, because we have updated only the values. Okay, so let me execute this code. If you guys have any concern, please make a comment over there. Thank you.